Algebras. Welcome to your Chapter 9 exam review, where I will do a couple examples and then you will do a couple examples, and we'll be getting ready to take our test on the information from Chapter 9. So here we go. The first thing we're going to do is to simplify our radical expressions that are given to us. So remember, in simplifying radical expressions, you look at the radicand, and the first thing you ask yourself is this radicand a perfect square? If your answer is no, like it is for number 1, 56 is not a perfect square. The second thing you ask yourself is, okay, is this radicand divisible by any perfect squares? And if the answer is yes, then you take this number and you divide it into two radicals, which are the perfect square radical and the leftover radical. Okay? These radicals are still multiplied together, and you're factoring that radical. But the thing is, you're pulling out that perfect square factor, which means the only options for 56 to be divisible by have to be 4 and 9 and 16 and 25 and 36 and 49 and 64 and 81, 100. You see where I'm going with this, right? Having to know what your perfect squares are. Now, obviously, those perfect squares have to be less than or equal to 56, right? So 56 itself, let's start with the first perfect square we can try, which is 4. And 56 is evenly divisible by 4. What's the leftover? 14. Now think about the leftover itself. Can 14 evenly divide by any perfect squares? Oh, so that's a good leftover. Okay, you found the biggest perfect square that divides evenly into 56. The leftover is 14. What's the square root of 4? 2. Now that is your coefficient in front of your leftover radical, where the radicand in the leftover can never come out of the radical. That's it. This is what it is. There's your answer. So 2 radical 14 is how we say the answer. And again, we've practiced that before, but do make sure you're reading those correctly. Okay, let's head down to this one over here, because I'm sure that this particular number is a little bit intimidating for you, right? So 147, let's try. Now let's see how this goes. 147 itself is not a perfect square that I was supposed to memorize, but let's start with 4, even though it's not even, so it's not going to work, right? Okay, but 147 divided by maybe 9. Well, of course that wouldn't work, because the digits of 147 don't add up to a multiple of 9, so of course. Let's try 147 divided by 16. Well, wait a minute, this won't work because it wasn't evenly divisible by 4. 147 divided by 25. Well, this won't work because it doesn't end in a 5 or a 0. Okay, 147 divided by 36. Well, that won't work because it wasn't divisible by 4 or 9. See how I'm figuring this out, what perfect squares to try? So let's get up to this next one, right? I'm exhausting perfect squares pretty quickly here and thinking, ooh, is this evenly divisible by a perfect square? So let's try this one. Aha. So you have to test these perfect squares to find the one that works, okay? So 147, radical 147, divides evenly into a perfect square of 49 and a leftover radical of 3. What's the square root of 49? 7. So 7 radical 3 is my final answer. All right. Just a recall. If your number under the radical is a perfect square, like in number 10, then what you do is you take that square root, and if there is already a coefficient, you multiply that square root by the coefficient. So 3 times 6 is 18. There's my answer, and that's now rational because it's a whole number. It's an integer, right? It's a rational number. Same here, and this is why I ask you to memorize those perfect squares up through 400, because 144 is a perfect square. So what I do is I take the square root of 144, it's 12, and I multiply it by this coefficient out here of negative 2. Negative 2 times 12 is negative 24. Okay. If you've got a perfect square, take its square root. Those are kind of the easier ones. Now, let's say you don't have a perfect square like number 11, but you still have a coefficient in front. You still do the same process of dividing the radical into perfect square and leftover. It's just now when you take the square root of the perfect square, once you figured out what it is, you now multiply that number by the coefficient. The biggest perfect square that divides evenly into 48 is 16. The leftover, right, just in case you forget about this from all the factoring that we did, 48 divided by 16 gives you a leftover of 3. So this leftover still will never come out of the radical. Square root of 16 is 4. Negative 5 times 4 is negative 20. And the radical 3 leftover comes on as the multiplied attachment at the end. Negative 20 radical 3 is your final answer there. Okay? There's a decent number of these for you to try. All right, so what I want you to do, pause this and give these other ones a try. Okay, pause it here and I'll, of course, insert a question. And we'll come back and we'll check how we're doing on just doing the regular simplification in a moment. Okay, pause it here. Make sure you give these a try. That's really important to make sure you're doing. We're back. Check your red answers. Anyone notice the duplicate? Number 2 and number 8. So in something like number 9, where 32 is evenly divisible by more than one perfect square, I go for the biggest perfect square that's evenly divisible into 32 so that I only have to simplify once. If you didn't get out the biggest perfect square the first time, that's okay, but you're going to need to keep simplifying until that leftover is not evenly divisible by a perfect square. Okay, so you do want to be watching for that, looking for the biggest leftover. Also, be sure that the thing you're taking the square root of is the perfect square, and the leftover is the number that's still left under the radical. So you have to take the square root. You can't just say, oh, radical 18, okay, it's divisible by 9. Let's put 9 out front and leave 2. You got to take the square root of 9. 3 is what comes out as the coefficient. Radical 2 is that remainder. 3 radical 2 as the number is the final answer. Okay, and just to show you how that kind of thing works, 3 radical, oops, I need my radical, 2, there it is as decimal, right, is the same as radical 18. So you can always double check in your graphing calculator to make sure you've got the correct simplified version, because they will come out as the same rationalized decimal. Even though it's a non-repeating, non-terminating decimal, this is your graphing calculator rationalizing that decimal to the best of its ability. Okay. All right, continuing on review. These were some situations that we found ourselves in, oops, other way, where we have to get our x alone. Okay, so this was one of the things that we worked on. We have to get our x alone. So I'll do a couple of these and then leave you to try a couple of these. Okay, we can't leave any perfect square factors under radicals. So if ever there is one, we take it out. So when I look at number 17, when I've got a plus and minus like this over here, first I want to move the number that's next to the x by its opposite sign. Now that does leave me the x alone. This number now goes in front of the plus or minus. And what I do with this radical is I simplify it. So the first thing I ask myself is, okay, is 49 a perfect square? So I can take its square root. So it comes out as plus and minus 7. Now, when these two numbers are in the same number set, like these are, you actually add them and you actually subtract them. So I'm going to get two answers for x here. 4 plus 7 is 11. And 4 minus 7 is negative 3. There you go. There's your answers for x. Now I'm going to contrast that with number 18, where, yeah, I have to move the 7 by subtraction and it still goes in front of the plus and minus. But this time, 99 is not itself a perfect square. Now, is 99 evenly divisible by a perfect square? Yes. It's 9 and the leftover is 11. What's the square root of 9? 3. So 3 radical 11 goes in place of the plus and minus radical 99. So I put this here instead. Now I'm just look, these are not like terms, so they cannot combine any further. That is where I stopped for my final answer. Let me do some of the fractional ones. Now, in the fractional version, x is already alone, but you still have to simplify the radical yourself. So in number 21, 36 is a perfect square. Cool. Okay. So bring it down. So x equals 3 plus and minus 6 over 2. Well, let's think about what these two scenarios are. And these are all integers, so we can do this, right? 3 plus 6 is 9. 9 does not evenly divide by 2, so I'm going to leave it as a fraction. 3 minus 6 is negative 3. Negative 3 does not evenly divide by 2, so I'm going to leave it as a fraction. Fractions are fine. Fractions are fun. Whereas on number 22, radical 44. 44 is not a perfect square, but 44 is evenly divisible by the perfect square 4. So I simplify it into radical 4, radical 11. Square root of 4 is 2. So 2 radical 11 goes back in that place. You get x equals negative 4 plus and minus 2 radical 11 over 8. Now what you look at in the fraction version is, are the coefficients all evenly divisible by the same number? Negative 4 and 2 and 8 are all even numbers, so they're all evenly divisible by 2. So negative 4 divided by 2 is negative 2. 2 divided by 2 is 1, so I'm just going to leave that 1 radical there. Okay, the radicand doesn't get affected, only the coefficient. And then on the bottom, 8 divided by 2 is 4. There's my final answer. Nothing can further combine because we've got this irrational number here. It's not going to be able to add and subtract with my rational negative 2 over here. Okay, so I'm going to leave you guys to try 19, 20, 23, and 24. Again, give those a try. Use the 4 I've done to help you, and we'll check our answers in a sec here. Okay? Give them a try. I'll be right back. And we're back. Just going to scooch this guy up so you can see my red answers down here. Okay? Make sure you have those correct. All right. I guess rationality is what we have left to give a try, right? I'll make sure you have those correct first. Okay. And here we go. So we've got a couple of these, let me do 1 or 2. A lot of same statements as what we had in our homework. So let me just try a couple of them and then you try a couple and we'll finish up. Okay. So let's see. We've got W is irrational because that number under the radical is not a perfect square. X is irrational because that number under the radical is not a perfect square. Rational for Y because square root of 49 is 7. Rational for Z because square root of 36 is 6. So rational results in, and look at all the choices, they're all adding. When you have a rational plus rational, you get rational. So any combination of number sets is not going to give me a rational result. So I want to look for Y plus Z, right? So where do we see Y plus Z? Choice 2. Okay. Let me just do 27. I'll leave you 26 because it matches so closely to number 25. But number 27 is multiplying. If I look at all my choices, they're all, touching without any sort of sign in between. So that's indicating multiplication of those variables, right? So when it comes to multiplication, you kind of have to be careful about what's under the radical. And if you have a like result under the radical, a like radicand, you automatically get a radical result. Okay? So I can't, if I want an irrational result, I need to have a mixing of the rational and irrational multiplied together. Okay? I need to have that mixing. So I can't have W times X, which of course is this first one. That's not going to be an irrational result because they have the same radicand. So Y times Z, well, those are both rational, so that's not going to give me a rational result. And then actually, look, the commutative property says these two things are going to give me the same result. So it's got to be choice 3. Be careful on that, right? Okay. Let me do the next page of which is not always true, and then do one of these integer problems, and then we'll let you guys try a couple of them, okay? So which statement is not always true? The sum of two rational numbers is rational. Sum, adding, right? Adding, this is always true. The product of two irrational numbers is rational. Sometimes, not always. And we're looking for an always true. So my choice is going to be 2, but let's just read through what the other things are that are always true. The sum of a rational number and an irrational number is irrational. Yep. A mixing of number sets, the result is irrational. For sum, for adding. The product of a non-zero rational and irrational is always irrational. Yes, and we just saw that on the example I had just done on the other page. Which domain would be most appropriate for a function that predicts the number of cars? Okay, cars has to be whole numbers. You can't have the negatives. You can't have radical 2 number of cars, and you can't have half a car. So it's got to be whole numbers. You try 32, 28, and 26. Okay? So you try 32, 28, and 26, and we shall be right back with those results. Okay? All right, and we're back. So what do we think? Any issues on these guys? Boy, I hope not. I think you're getting ready for this test. Shouldn't be too bad. Really just one thing we're kind of focused in on here, and that's that simplifying radicals and understanding if your answer is rational or irrational. Okay, that's it. That's what we're looking at in this entire chapter. Okay? Please make sure that you have all these answers correct. Again, with the video, of course, I'll have the answer key so you can make sure as you're trying these yourself and getting ready for your test, you know how you're doing. Okay? This has been your Chapter 9 exam review. Guys, good luck on the Chapter 9 exam, and I will see you in Chapter 10, which is another great application right away of the skills we're just going to learn here. Good luck. I'll see you soon. Bye.